How's it going, everybody? Today we're going to do Geometry Basics 3, which makes me really happy because the last lesson we were naming things. It was basically name this line, name this point, name this plane. Drives me crazy, I'm not going to lie. Today we get to do actual math, which makes me really happy. So let's jump right in here. Postulate number 5. We did 4 postulates before, so it makes sense. This would be the 5th one. It says every point on a line can be paired with a real number. The real number is called the coordinate. And what you should be thinking when you hear this is you've got a number and it's on a line. Okay, well, number lines. We've done this. Okay, so that makes pretty good sense. Now, this postulate is known as the ruler postulate, because essentially that's how a ruler works. Okay, somebody decided, hey, this is what we're going to call an inch. You know, this is what we're going to call a foot, etc. So, basically it's saying if you take a line, you can designate different spots on that line using numbers. And it makes a correspondence between points on a line and real numbers. So basically the coordinate. So we could just say this on the line. We're just going to call it 0. You know, we're pairing each point on the line with a real number. So we're going to say this is 1. We're going to say this is 2. And this is, you get the point. So I'm just going to move on. The next one and the last one, if 3 points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. Now, what you may notice, I'm not sure if you noticed, I'm not sure if you cared, but I'm just going to throw this out there. We no longer have the symbols above the letters. So when you look over here, AB plus BC equals AC, but did you notice in the last section, we actually, when we had a line, we would name it line AB, and we had to put the symbol over it. Or a segment AB, we had to put the symbol over it. When there is no symbol on top, what that tells you is that we are dealing with the distance between. We're dealing with a measurement of the distance in between. And at this point, suddenly it makes a little bit more sense. The distance from here to here, the measure of the length from here to here, plus the measure of the length from here to here, equals the measurement of the whole thing. The part plus the part equals the whole thing. Now, we can do that all the time. We can create a whole lot of different problems relating to that. And one of the ways that we work through that is with some number line examples. So let's say we were on a number line, and I'm just going to put 0 right here, and then we need to put A, B, and C in some different locations so we can practice this idea here. Okay, so let's go here, here, and here. We will put point A at, we'll go -7. Okay. We will put point B at, I don't know, we'll say -2. And we will put point C at 9. Okay. So if you counted the distance from A to B, so that would be essentially the difference between these two numbers, essentially. So -7 minus -2, or you could go the other way around, -2 minus -7. And then remember, distance is always positive. Nobody ever says they walked -5 miles to school. So if you're just counting or if you're just subtracting, no matter how you look at it, you should know that those two numbers are 5 units apart. That doesn't seem unreasonable, so let's go with it. Now, from B to C, this is where kids get it wrong because you're going from -2 to +9. So you have to go 2 jumps just to get to 0, and then 9 more jumps. Now, last but not least, remember what we just said. The part plus the part equals the whole thing. So it would make sense that you've got 16 total. Okay. Now these examples, it says they're ranging from easiest to most difficult. So let's step it up here. Let's do a little bit better here. So we got E. We've got F, which is going to be about 2/3 of the way down. Now I just want you to draw these for yourself, and I want you to start seeing what's going on here. So E, F, G. So EF is 37, EG is 56. What is FG? Now this goes back to what we just said. The part plus the part equals the whole. And oh, the humanity, our first appearance of algebra. The part plus the other part. We don't know the other part. Wah, wah, there you go. We actually have an appearance of the letter X. You knew it was going to happen at some point. Here it is. So the part plus the part equals the whole thing. If you break something up into 2 pieces, then the part plus the part equals the whole thing. 37 plus X equals 56. And now this is just going to be a matter of how much algebra do you know. And I would assume if you were in a geometry class, you could do a one-step equation. So we're going to subtract 37 from both sides. We're going to find out that X equals 19. And that means, as far as the context goes, like what does X actually mean? It means if we wanted to answer the question they gave us, what is FG? FG is 19. All right, let's step it up a little bit. If we're going a little bit too fast, I apologize. Remember, you can always pause the video if you need to. All right, now we're getting somewhere. QR equals 2x plus 3. RS equals 5x plus 4. And QS is 42. Okay, so we've got a Q. We've got an R. We've got an S. Now, it doesn't matter exactly how you draw this. What matters is that you understand what's actually going on. But this is going to be sort of a 3-step equation in algebra land because, again, just like we said, and this is getting repetitive, but I think you get the idea. The part plus the part equals the whole thing. So what is QR? Well, we don't know what QR is, but we know that it's 2x plus 3. So I don't actually know the value, but I know that it's 2x plus 3. Then you've got the other part, which is 5x plus 4. And then we talked about it, the part plus the part equals the whole, which is 42. Now, if we combine all this, that's going to give you 7x plus 7. 2x plus 5x is 7x, 3 plus 4 is 7, and again, that's going to still equal 42. At this point, it just becomes a 2-step equation, so we kind of had 3 pretty big steps, but what we're going to do here, we're going to subtract 7 from both sides. Okay? And I think you knew that, but if you didn't, or if you forgot everything there was to know about algebra, you're in the right place because I taught algebra for a really long time. 7x equals 35. From here, I think you know the last step, and I'll just draw it with a mouse. I'm not going to type it out, but you just divide both sides by 7, and you get x equals 5. Now, this is one thing in geometry class I have to guard against. Don't just say x equals 5. You didn't actually answer the question. I mean, yeah, we know x equals 5, and that is a good thing. But what I want to know is what are QR and RS. Okay, that's the more important detail. I want to know what QR is, and I want to know what RS is. So, if you don't actually tell me, you don't get the points. Okay, so if you were to go back and plug in 5, you would get 2 times 5, which is 10. Remember, we're plugging 5 in for x. Now that we know that x equals 5. 2 times 5 is 10, plus 3 is 13. And then 5 times 5 is 25, plus 4 is 29. So QR is 13. RS is 29. Okay? Now, let's go to setup number 2. Instead of the part plus the part equals the whole thing, now we're going to get into a key word here. And you actually did this back in the day. You actually did midpoint. This is not new. Okay. Y is the midpoint of xz. That means the distance from here to here is the same as the distance from here to here. And actually in geometry class, that's a very common thing to do. In geometry, if we have 2 segments that are the same length, we usually mark them with the same marking. So you notice how I put 1 mark through this, 1 mark through this. That is very common. That's pretty much what we do on a regular basis in geometry class. Get used to it. Now, here xy is 3x minus 1 and yz is 2x plus 19. So here, instead of saying the part plus the part equals the whole, what I want you to do instead is just take the 2 parts, and since we know they're the same, just put them equal to each other. So that's going to be the key to success in this section, is knowing when to do each of the 2 setups. So either the 2 parts add up to give you the whole thing, or the 2 parts are equal to each other. So here, what I'm going to do, I'm just going to subtract 2x from both sides, so a little more algebra here. And that's going to give me 3x minus 2x, which is just x, minus 1 equals 19. Once we make it there, and once we say that x minus 1 equals 19, now we could just add 1 to both sides, wrap up the problem, and find out that x equals 20. But hopefully you remember that isn't actually what I wanted. What I wanted to know is what is xy, what is yz, and what is xz. That's the key. So those are the questions that we need to answer. xy, you plug that number in. X is 20. 3 times 20 is 60. 60 minus 1 is 59. Now, I guess we could save ourselves the trouble. If we know that yz is the same as xy, we might as well just write 59 again. Now, I don't know if you checked, but if you did, you would get 59 either way. Xz would be the entire distance, which would be 118. It's just 59 plus 59. The last one we're going to do, number 6, will be a test for yourself that I want you to try without drawing it. Find the length of each segment if MN equals NP equals PQ, QR equals 10, and MR is 31. I love that. This is what it's all about. Now, the reason I like this question is because it forces you to really draw things out. If you don't draw things out, then there's a good chance you're going to get it wrong. So I like questions that force a student to actually draw. Now, here's the deal. I know that QR is 10. I don't know any of the other pieces, but I know they're all the same. So I think your best bet here is to take these 3 things you don't know, and since we don't know any of them, just call them all x. That's what I'm going to do. So when I set up my equation, I'm going to say x plus x plus x plus 10. So the part plus the part plus the part plus the part equals the whole thing, which is 31. Now, x plus x plus x is 3x, which means I can create a 2-step equation from here. So my last 2 steps, I'm going to subtract 10 from both sides. And from there, that would give me my 1-step equation, because now I've got 3x equals 21. And if 3x equals 21, you would divide it out, you would find out that x equals 7. So it said find the length of each segment, so let's actually label this correctly. Remember, if we're just referring to the length, we don't have to put a symbol above. We're just going to say mn is 7. Now, we didn't use the letter O. Like, I don't know if you were thinking about the alphabet and you're like, where'd the letter O go? The letter O looks too much like a 0, so generally we don't use it. A lot of times, maybe with circles we do. Sometimes you'll see it, but we're not going to do it right this second. And obviously, we already knew that QR equals 10. So when it said find the length of each segment, that will do. So thanks for watching. Hope this is helpful, and I'll see you next time.